Yet again, we are going to solve an amazing math question from the previous video. Hope you enjoy it. Given the equation 4 times x minus 2 all in bracket squared is equal to k times x minus 1, show that the sum of its roots is equal to their products. B. Find the values of the constant k for which the difference between the roots is 3 whole number 3 over 4. Let's dive into it. Okay, the solution. So this is the equation. We want to expand this equation to write it in a quadratic form. A form ax squared plus bx plus c. So this is what we get. We know x minus 2 all squared is equal to x squared minus 4x plus 4, applying the Pascal triangle. And k times x minus 1 will be kx minus 1. Okay, keep on expanding. So you multiply 4 by all the terms in the bracket. So we get 4x squared minus 16x plus 16 is equal to kx minus k. Now we bring kx and k to the other side of the equation, the left hand side. When kx is coming to the left hand side, it becomes negative. And negative k becomes positive k. Want to equate it to 0 so that we can find we can locate a, b, and c. So what do we do here? We can clearly see the one with, so the form we want to write it in this form. Clearly see to be what 4. What about b? B is there, but I want to write in the form where b will be uniform. Here you can see you are seeing minus 16 minus k. So let's write it like this. Let's bring out minus 1 and x. So what do we get? So 4x squared minus into bracket 16 plus k. So we brought minus 1 out, as you can see. So a is equal to 4. B is equal to minus 16 plus k. That one is in bracket. And c is equal to 16 plus k. Since they are the ones with no x, or the power of x in them is 0. Okay, let alpha and beta be the roots. Let alpha and beta be the roots. So for a, the question was, show that the sum is equal to the product. So first of all, let's find alpha plus beta. We know alpha plus beta is equal to minus b over a. We have a b to be minus into bracket 16 plus k. That's what we have here. And our a value is a is equal to 4. We have it here. So minus minus, we get positive. Nege 4. And this is what we get. 16 plus k over 4. Let's name it equation 1. Now, alpha beta, which is the product, is equal to c over a. And clearly see as c and a. So 16 plus k over 4 is equal to 16 plus k over 4. So we can make a concluding statement that since equation 1 is equal to equation 2, the sum of its roots is equal to the product of its roots. Simple. Now let's move to B. From the question, the difference between alpha and beta is 3 whole number 3 over 4, the roots. Take any two numbers. Just take any two numbers. So I'll take 2 and 4. What's the difference between 2 and 4? The difference is what? 2. The difference is 2. Right? So let's say in this case alpha. What would be 4? Alpha plus 2. So as we said, the difference is 3 whole number 3 over 4, which is equal to 15 over 4. If one is alpha, then the other will be what? Alpha plus 3 whole number 3 over 4. Considering the fact that beta is bigger than alpha. But if alpha is bigger than beta, then it will be alpha and alpha minus 3 whole number 3 over 4. But let's assume beta is bigger than. Let's just assume. Okay, let's continue. So from earlier discussion, we said alpha plus beta is equal to 16 plus k over 4. So we can find a new expression for beta and say alpha plus 15 over 4 is equal to 16 plus k over 4. So 2 alpha plus 15 over 4 is equal to 16 plus k over 4. Now we can see some fractions here and there. So what do we do? Let's clear the fraction by multiplying through by 4. We multiply through by 4. The 4 being the dividend of 16 plus k over 4 will go away. The same for 15 over 4. But the 4 multiplied the 2a to get 8a plus 15 is equal to 16 plus k. Let's try and make k the subject and see how it can help us. So k is equal to 8 alpha plus 15 minus 16 means 8 alpha minus 1 is equal to k. This is very important. Let's keep it in our head, in our mind, so we need it again. Okay, now let's also find an expression for alpha beta. So from what we did first, alpha beta is equal to 16 plus k over 4, right? Okay, so we can find a new expression for that and say alpha times alpha plus 15 over 4 is equal to 16 plus k over 4. Alpha times alpha, alpha squared. So alpha squared plus 15 over 4 alpha is equal to 16 plus k over 4. We can see a fraction here again. So let's clear the fraction. When we clear the fraction, we get 4a squared. Get 4a squared plus 15a is equal to 16 plus k. Well, I've already talked about it here that k is equal to 8a minus what? 8 alpha, sorry, 8 alpha minus 1. If that is so, then we can put that into this equation and get 4 alpha squared plus 15 alpha is equal to 16 plus 8 alpha minus 1. We bring 16, 8 alpha and minus 1 to the other side of the equation, the left hand side. So 16 becomes negative, 8 alpha becomes negative, and minus 1 becomes positive 1. Well, let's arrange it once and for all. So let's associate those with alphas. Okay, so 15 alpha minus 8 alpha, we get 7 alpha. Then minus 16 plus 1, we get minus 15. So our new expression is 4a squared plus 7 alpha minus 15 is equal to 0. The factors of this quadratic equation is into bracket 4 alpha minus 5 alpha plus 3 is equal to 0. So for each of them, you can see 4 alpha minus 5 is equal to 0. Alpha plus 3 is equal to 0. Alpha is equal to minus 3. Now let's come back to 4 alpha. So 4 alpha is equal to 5. Divide through by 4. Alpha is equal to 5 over 4. Good. Now alpha is equal to when alpha is equal to 5 over 4. K. When alpha is equal to 5 over 4, k is equal to 8 times 5 over 4 minus 1. And what do we get? This 4 will go into 8 2 times. 2 times 5 is what? 10. Good. So, get k is equal to 10 minus 1. Let's come to this side too. When alpha is equal to minus 3, k is equal to 8 times minus 3 minus 1. K is equal to minus 24 minus 1. K is equal to 9 on this side, and k is equal to minus 25. So when alpha is equal to 5 over 4, k is equal to 9. When alpha is equal minus 3, k is equal to negative 25. You might think we are done. Yeah, we are. But I want us to look at another way of solving b. Yeah, but before we look at that way, I want us to look at this. I have to know these things. So from Pascal's triangle, you can employ it here as alpha plus beta all squared is equal to alpha squared plus 2 alpha beta plus beta squared. Let's rearrange this and write it as alpha plus beta all squared is equal to alpha squared plus beta squared plus 2 alpha beta. Making alpha squared plus beta squared the subject, we send 2 alpha beta to the other side. So we get alpha squared plus beta squared is equal to alpha into brackets alpha plus beta all squared minus 2 alpha beta. Good. Also, alpha minus beta all squared is equal to alpha squared minus 2 alpha beta plus beta squared. Let's rearrange this one too as alpha squared plus beta squared minus 2 alpha beta. Well, we've already found alpha squared plus beta squared. So let's substitute that into alpha minus beta all squared is equal to alpha squared plus beta squared minus 2 alpha beta. So alpha squared plus beta squared is equal to into bracket alpha plus beta all squared minus 2 alpha beta. Putting that into this one, we get alpha minus beta all squared is equal to alpha plus beta minus 2 alpha beta. We will put this into this. Put this into this. We get alpha plus beta all squared minus 2 alpha beta. And this 2 alpha beta is already there. So minus 2 alpha beta. And we get alpha minus beta all squared is equal to alpha plus beta all squared minus 4. Okay, knowing this, what do you think alpha minus beta will be? To simply be the square root of into bracket alpha plus beta all squared minus 4 alpha beta. Simple. Good. Okay. Knowing this, how can they help us? Let's look at it. So from the question, the difference between alpha and beta is what? 3 whole number 3 over 4, which is equal to 15 over 4. We've already said that. But alpha minus beta is equal to root alpha plus beta all squared minus 4 alpha beta. Good. And so knowing this, we can join the two expressions. We can say root this is equal to 15 over 4. And we've already found alpha plus beta to be 16 plus k over 4. And that's the same as alpha beta. Knowing that, we have to fix it or substitute into this equation. So we get root this is equal to 15 over 4. Now that we have this, we can see something here. And cancel this 4 and get 1. We take this 4 away. Straightforward. We'll not wait for anything. Okay. After doing this, we get into bracket 16 plus k all squared over 16 minus 16 plus k. Now we throw the square root sign away from the left hand side. How do we do it? By squaring both sides. When you square both sides, the square root sign on the left hand side disappears. Now the square root sign has run away, and now by square. So this is what we get. Let's compute and see what we get. We get 16 plus k all squared over 16 minus 16 plus k is equal to 225 over 16. How did we get 225 over 16? I hope you remember this. Yes, that's the reason why. So 15 over 4 all squared is equal to 15 squared over 4 squared. And 15 squared is 225. 4 squared is what? 16. That's how we got it. We can see a fraction again. So let's clear the fraction. So those with 16 as their dividends will have no dividend. The dividend will be 1, which is the same as the thing. And 16 will multiply the into bracket 16 plus k. We get 16 plus k all squared minus 16 times 16 plus k is equal to 225. Let's do the expansion. So using Pascal's triangle, we can say 16 plus k all squared is equal to what you are going to see. We get 256 plus 32k plus k squared minus 256 minus 15k is equal to 225. We've expanded the whole thing. Now we can see this minus sign. Since they are unlike, we can take them away so that they'll go and continue their friendship somewhere else. Now let's rewrite the whole thing nicely. Always the work should be nice. So how do you write it nicely? Okay, so we can write it as k squared plus 32k minus 16k minus 225 is equal to 0. Get a new expression to be k squared plus 16k minus 225 is equal to 0. The factors of this quadratic equation is k minus 9 into bracket k plus 25 equal to 0. Meaning that k is equal to 9 or k is equal to minus 25. I think we are done. Yeah. So choose the one you like, either this way or the other way. It's up to you. But let me give you a challenge. Um, Find the roots of the equation in this video. So the equation we've talked about. Find the roots. Answers are to be expected in the comments. I'll be expecting your answers. Thank you very much for watching. Next time.